Now, the first limit I want to look at is the limit as x tends to 5 of 3 plus x. So if x was to reach the value of 5, we'd end up with 3 plus 5, which means in this case the limit is 8. The next one, let's do the limit as x tends to 5 again, and this time 15 minus 3x, and if x was to reach the value of 5, we'd end up with 15 minus 3 5s, which is 0. Nothing wrong with the value 0. The next one I want to look at is slightly different though. So we've got the limit as x tends to 5 again, but this time we've got 1 over 15 minus 3x, and this time if x was to get to the value 5, we've got 15 minus 3 5s again, which is 0, and that gives us 1 divided by 0, which is not defined. So here we'd say we have no limit. Then we've got the limit as x tends to infinity, and that gives us 5 over x, or the limit as x tends to infinity of 5 over x, and because we've got 5 divided by an increasingly large number, that gets closer and closer to 0. As long as the numerator doesn't tend to infinity as well, we can safely put 0 as the limit in cases like these. We've got one more case we want to look at, and it's going to look a bit like the last one, but it's going to have some slightly different solutions to it. So let's go for the limit as x goes to 2 of x squared minus 2x over x minus 2 x plus 5. Now, if x was to get to the value of 2, the numerator would be 0. Nothing wrong with the numerator going to 0, but then the denominator goes to 0 as well. And if you've got 0 on both of them, and this is true if you've got infinity on both of them as well, then what we actually want to do then is see if we can simplify the function. So what I'm going to do is I'm going to factorise the top, and that's going to give me the limit as x goes to 2 of x minus 2 over x minus 2 x plus 5. And we can see that x minus 2 is a factor of the numerator and the denominator, so they'll both cancel out, and that gives me x over x plus 5. And if x was to reach the value 2, we'd end up with 2 over 7.